Here we have an application of a linear equation passing through 2 points. We're given the median home price in Austin as $96,000 in 1994 and $156,000 in 2002. We're asked to find a linear equation, so that's our first clue that we're going to be using these formulas, such that y is the median home price. All of this is important right now. Y is the median home price in thousands of dollars. X is the year. So the first thing I'm going to do is look at the information I'm given and designate X or Y. $96,000, that looks like a value of Y. In 1994, that's a year, so that's going to be an X. $156,000, that's going to be a Y. And 2002, that's going to be an X. Since these go together, I'm going to call the first one X1, Y1, and the second one X2 and Y2. And this is starting to look probably more familiar now as the problem of finding an equation of a line given 2 points. X1, Y1 is 1994, which is the year, and 96, I'm not going to put it in thousands because the units are already supposed to be in thousands of dollars. And the other point, 2002, and 156. So if I want an equation of the line through these 2 points, I just need to label them, right? Whoops. That's what happens when I talk and write at the same time. Okay, I need to label them and then think about the relevant formulas. I have to start with a slope. Slope of a line through 2 points is the difference in the y's over the difference in the x's, making sure to subtract in the same order in both cases. So the slope of this, I'm going to do 156 where I ended up minus where I started, minus 96, and again with the years where I ended up minus where I started. This gives me 60 divided by 8 years, which turns out to be 7.5. We can also think about what this number means and what its units are. This came from a change in thousands of dollars over years. So the meaning of this number is that median house prices were, or the median home price in Austin was increasing at a rate of $7,500 per year over that time period. On a problem like this, sometimes we're asked to interpret our rate of change, sometimes we're not. It's always good to make sure we at least would know how to do that if we are asked to. So to find this equation now, I need to think about whether the slope-intercept form of a line would be sufficient or if I need the point-slope form of a line. Because neither of these points is the y-intercept, right? Again, looking back at these points that I'm given, I know that neither of them is the y-intercept because neither of them has an x-coordinate of 0. I look back again, make sure this is how I was supposed to define x. X is definitely the year. It is not the number of years since 1994, so I can't just shift this whole thing and pretend that one of those was 0. So that means I really do need to use the point-slope form of a line. I have to use this y minus y1 equals m times x minus x1. And I'm just going to plug into it. X and y stay variables. Everything else gets plugged in for. Everything else is a constant. So y minus my y1 is 96. Whoops. My m is 7.5. And my x1 is 1994. This is an equation of a line This is a linear equation. At this point, this could be considered done because the instructions did not require a slope-intercept equation. If we wanted a slope-intercept equation, then we would have to multiply everything out. Then we would have to go a little further and say y minus 96 equals 7.5x minus what we get when we multiply, 7.5 times 1994, which looks like 14,955. Then I would add the 96 to both sides to get an equation in slope-intercept form. 7.5x minus, let's take that 14,955, make it negative, add a 96, and we get negative 14,859. This second equation is not in any way better than the first. There are sometimes reasons that we want a slope-intercept equation for something, but in this case, notice if we look at the first equation we got, all of the numbers have meaning, right? That 96 is in there because of the fact that there was an actual $96,000 median home price. That 7.5 is the rate of change, and 1994 is the year in which we had that home price, and x minus 1994 is the number of years since the houses were that price, at least on average. If we look at this second equation, the meaning of this y-intercept is really quite weak. It's theoretically the cost of a home in Austin in the year 0, right? But obviously it wasn't negative $14.8 million. Negative, I'd emphasize the negative $14.8 million to buy a home in Austin in the year 0, right? This model doesn't apply there. So the numbers in this equation don't have nearly as much meaning. Sometimes it's better to just leave the equation in point-slope form. If you're not told a specific form, don't assume you have to get your equation into slope-intercept form. We can use either of these to estimate the median home price in 1996. I will choose to use the point-slope form just because of the characteristics I was just talking about. So if we say y minus 96 equals 7.5 times, I'll just plug that 1996 in for x, and the rest of it is just the exact formula we already found. Then all along the way the numbers have meaning. The rate of change times the number of years since 1994, right? This ends up being 15, and we would just add 96 to both sides to get 111. So we would say that it was $111,000. The median home price in Austin was $111,000 in 1996, approximately, if this was, in fact, growing at a constant rate. Kind of makes you wish you had bought a house in 1996.